I know I'm starting with a lot on the board here, but this is for 32.b, and we're going to explain this so it's very simple to see. First of all, I have my Cartesian plane, my x and my y coordinates. When I start looking at those, I realize that x gets progressively larger this way, making it positive, and if I start at 0 and go this direction, it's a negative x, positive y, and negative y on my directions. Once I realize that, I can start putting some triangles in. So if we just pay attention to just our first quadrant triangles, that would be this quadrant over here. It's labeled with the Roman numeral 1. And we're going to start there because both the x and the y are positive. I'm labeled that way in this quadrant. If I move to the second quadrant, I realize that x ends up negative, but y stays positive. In the third quadrant, both are negative, negative x and negative y, because I'm going down and back. In the fourth quadrant, I'm going positive x and a negative y. So those are my combinations that I can have. Both positive here, one negative, one positive, both negative, the other one negative, and one positive here. Once I've done that, I'm going to go ahead and put my trig functions up, and I drew these triangles in each one of the quadrants to help us visualize how that works. Notice my sine is my opposite over hypotenuse. If I go into the first quadrant, which is this one here, and I look at my sine, remember the sine, and I'm going to put this is my theta here, this is the angle I'm looking for. My sine and my theta, well, sine is opposite over hypotenuse. Without worrying about what the value of the opposite is, I know my opposite is going to be here in comparison to theta. So my opposite over my hypotenuse, which is going to be a positive over a positive, and that's going to give me a positive. Whichever way it works out, it's still going to be a positive number. My cosine is adjacent over hypotenuse, which is going to give me another positive number. And then I have my tangent. Well, tangent is opposite over adjacent. A positive divided by a positive is still a positive. So all the trig functions are positive in the first quadrant. If I jump over to the second quadrant, I'll look at it and realize my sine function, which is opposite over hypotenuse, a positive divided by a positive, is still going to be a positive. But then when I go to my cosine function, my cosine is my adjacent. So I'm looking at this angle here and I say my adjacent angle is negative x. Right? Adjacent side is negative x. Negative x, so a negative divided by a positive. Well, a negative divided by a positive is always going to give me a negative value. Okay. And then I say my tangent function, and that would be my tangent is going to be my opposite over my adjacent, a positive divided by a negative, which is going to leave me with another negative. So my tangent function is negative in the second quadrant. Then I move to the third quadrant, and I start watching this one, and I realize this is my internal angle here, there's my theta, and I look at my sine is my opposite over my hypotenuse. Well, remember the hypotenuses are a radius, and radius are always positive, so this is going to be a sine function, is going to be opposite over hypotenuse, is going to be a negative. For my cosine function, it works out as a negative too. A negative divided by a positive is a negative. And then I look at that and I say, well, what about my tangent? Now, tangent's a little unique here because it's opposite over adjacent. And opposite is a negative. My adjacent is a negative. And a negative divided by a negative is a positive. So I'm going to go ahead and put a little positive here. I move to the fourth quadrant, and I have values here. And I look at them and I say, well, what about my sine function in the fourth quadrant? Once again, this is my theta here. My sine function in the fourth quadrant is going to still be opposite over hypotenuse. The opposite is negative, the hypotenuse is positive, which makes that a negative. If I move to the cosine is a positive x divided by a positive radius, and that's going to give me a positive. And then my tangent is going to be opposite over adjacent, which is a negative divided by a positive, and that gives me a negative. Now, what I want us to realize here, or what this lesson is about, is realizing that in the first quadrant, all the trig functions are positive. In the second quadrant, 2 of them are negative, only 1 of them is positive. In the third quadrant, 2 of them are negative, 1 is positive. And in the fourth quadrant, 2 are negative and 1 is positive. So if we started to, an easy way to remember this, I'm going to say in the first quadrant, they're all positive. Well, there's only 1 positive in the second quadrant, and I'm going to say that is my sine. And then I look at the third quadrant, I still only have one positive. It's really easy to remember. Everything's negative except for the tangent. So in my third quadrant, I'm going to do my tangent. In the fourth quadrant, the only one that is positive is the cosine. So if I write my fourth quadrant up here and my cosine. Now, a lot of people will remember this by saying all students take calculus to remember first, second, third, and fourth. If that works for you and you want to remember it, all students take calculus, and you can very easily say that's the only positives. Well, they're all positive in the first, the sine is positive in the second, the tangent's positive in the third, and the cosine is positive in the fourth, and you remember it that way, that's fine. I found it easier for me to go ahead and just sketch this. If I sketch any triangle in there and think about what is the cosine or what is the sine and figure that out in my head, I can very easily see what that is without having to have one more thing of memorization. But if you're a learner that likes to memorize, all students take calculus, and you can remember which one of the quadrants are the trig functions positive in, that's the easiest way to do it.